Hi guys, welcome back to our last segment of the show for today. So here we are looking at also the riders that have to do with similarity, right? We've been looking at that. So here it's going to be now just over the riders of just similarity alone. We're now going to be looking at tangents and what do they mean, and also some angles on the same segment, what do they mean. But I know you've done all these theorems. It's just that we are no longer just making it to be similarity alone. We're making it across Euclidean geometry so that you can see how we can link everything, right? So let's look at the first question. Here it says VQ is a diameter of the circle with center O. Immediately I know there's a diameter and a center. I'm pausing there and I want to see whether I can do something on my diagram. If I had any angle that was subtended by this diameter on the circumference of the circle, then I would definitely make it a 90 degrees, but there isn't any at this point. And then the chord EU is drawn parallel to the tangent. Immediately they are saying tangent. Guys, I run to my diagram because that gives me some interesting information for me to look at, right? So if this is a tangent, it means this is a 90-degree angle between the radius and that particular tangent that I have there. And since they are parallel, then it will be co-interior angles, corresponding angles, and some alternate angles there. And now the last statement is the point R lies on the tangent to the circle such that I have that perpendicular relationship, and they've actually shown us on the diagram. Now we need to prove that VNU. So remember, go to the diagram, show what triangle they want you to focus on. So V, that's where I start, N, where is my N now? So I think my N is supposed to be there by where the radius is intersecting the EU line, right? Yes, so it's supposed to be there. It cuts VQ at N, yes, so my N will be there. Sorry about that. So this triangle here, we need to prove that it is similar to QER. QER. Now, the very special thing about this one now, what I like about this is, it's no longer like the other similarities that we've been doing where it's one small triangle in a bigger triangle. No, it's one triangle there and one triangle there. Now you need to show some similarities in terms of either sides being in proportion or angles being equal to each other, then claim that they are similar. So this is really a very nice question for you to please look at. So let's see how we do that. Now, so with this one, what do I know? I know that they told me that these lines are parallel to each other, and this is a 90 degrees. So that's the first thing I'm going to say, right? Then I'm going to first say VQ is perpendicular, right? That's the very first thing I'm going to say, to RQ. And my reason for this will be radius perpendicular to tangent. Are you with me? This. And then from there we can then say that in that particular way of me saying that, I will know that my VNU as an angle is equal to 90 degrees, right? And why am I saying that? It will be because of corresponding angles. Corresponding angles, and that's because I was told that my RQ is parallel to EU. And then if that is the case, I will then also have my E1 as 90 degrees. That was given to me. E1 is 90 degrees. This was given, right? I'm just going to say this is given, right? Then what I need one more angle that I can link so that I can then make these things to therefore be similar to one another, right? So already I have one angle that is 90 degrees, so I must try and show that this angle here, or claim that this angle here, which is V, is equal to that angle there, right? Which is the angle E2, and therefore try to use that in the other triangle to then see whether it can be linked to this angle here because of alternate angles, you see. So I will say my angle V is equals to angle E2, and my reason for this will be because angles in the same segment, right? Same seg. And then because of that, E2 will also be equals to Q1, and this is because of alternate angles. Guys, maths is very beautiful. I hope you are enjoying as much as I am. And then because of that, I can then claim that V is equals to Q1, and the reason for that is both of them are equal to E2. And then you can then claim that the two triangles are similar after talking about the third angle that is equal, and then your reason will be angle, 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 and therefore you will then be done with that. Now, let's look at this one here. It's still the same question. They just want us to now show the concept of the ratios. Now, I want to rewrite this in the way that you might be used to, but just know that there are alternatives of writing ratio. This is the same as En over Vn, which is the same as Er over Eq, right? So I'm going to go back to what I proved as my similarity there. It's Vnu and Qer. So I proved that Vnu and Qer are similar, Qer. Then I will see whether I do have all of these things that are there, right? What do I know? They want me to have En, right? So En is not there on the diagram that I have, but I know that En is going to be equal to Nu. Why? Because of line drawn from center perpendicular to chord. So I will therefore say, remember this is my required to prove, right? Not that that's where I am starting. I just showed you how to write it in the way that you are used to. So I will use Vn. Why Vn? Because that's what is equal to En, right? And then I will also use my Er there. I need Er. There's Er. So Er goes with Nu, and then my Eq there. So my Eq is also there. So this will be Vn over my Un, which is equals to Qe or Eq over Er. And then I can just rewrite this in the order that they want, right? So I will just say Un over Vn. Why am I writing it like this? Because my Vn is the denominator according to what they want me to prove. This is Er over Qe or Eq. I didn't change anything. And then before you can then solve this, you will then say, but I know that my Un is equals to En. And my reason for this will be line drawn perpendicular to chord, right? Line drawn perpendicular to chord. Therefore, it makes this to be therefore En over Vn is equals to Er over, I will just write this as Eq so that you can just see what it is, right? And then you would have proven what they wanted you to prove. Now, let's look at, as soon as they start giving you some values now, then it means they want you to find some answers in terms of numbers and not just the ratios like we've been doing, right? So I know that my Nu is equals to 6 units. So Nu is 6 units there. Right? Remember, N is at that point. And my Vn is 12 units. So that's 12 units. And this will be 6 units as well. Remember, line drawn from center perpendicular to the chord. And Er is 4 units. So my ER is 4 units. What do they want? We need to calculate the length of QR. So I want to find this length here. So I'm going to go back again and look at the ratios that I've actually spoken about, right? So remember the triangles that we spoke about was VNU and the other one, the angle at V, so it's VNU and QER and QER, right? So I'm going to try and make sure that all these ratios that I have here, they have the sides that they gave me, right? They gave me NU and it goes with ER. ER I'm also given. What do I want? I want QR. So QR will be that one. It must be the same as VU, right? So do I know what VU is? No. So firstly, I use the theorem of Pythagoras in order to find the VU. So you will find this using the Pythag, right? And by that I mean VU is actually going to be equal to the square root of 144 plus 36. Someone might ask, where does the 144 come from? It's the 12 squared. The 36 is the 6 squared. So let me quickly press that on my calculator. The square root of 144 plus the 36 will give me 6 root of 5, right? So already this is 6 root of 5. So you see, now I have all the information that I need. So I said this will be NU over VU, right? Which is equals to ER over QR. And then what do they want me to solve? Is the QR. So my NU, I know it because I was given it's 6 over my VU is what I just found now, which is 6 root of 5, and this will be equals to my ER, I also know it, it was 4 over QR. So I'm just going to rewrite this. So the 6 and the 6, already you can see that they're going to divide each other, right? So now I'm left with 1 over square root of 5 is equals to 4 over what they want me to find, which is QR. Therefore, my QR is equals to 4 square root of 5. You can't simplify this further. Remember what the instruction was. You need to leave your answer in the simplest set form. So don't then try to then go to your calculator to get this in decimal form. All right, so another question now that we have here is AGDE is a semicircle, right? Semicircle meaning that it is half a circle, right? And AC is a tangent to this. So if this is a semicircle, it means that that angle there is 90 degrees and that angle there is 90 degrees. And then I know that I have a tangent as well that introduces the tangent chord theorem. And EG produced intersects AC at B, there is my B there, and AD intersects that BE in F, right? And then lastly, they tell me that AG is equals to GD and E1 is equals to X. So let's see what they want us to do. So immediately, before I can even answer this thing that they want here, I'm just going to show you these angles, right? So this is going to be X, Y, because of same segment. So you will just write them down in order there. And then this will also be equal to X after that. And the reason for that will be angles opposite equal sides. And then from there, I need 2 more angles. They said 4 angles, right? I need 2 more angles. I know that this is a tangent. So if this is a tangent, firstly, that will be X there. It will be same segment as well. Same seg. And then lastly, this one, which is 3, will be X as well. And that is tan chord, you see. So already you can just write those down, and those will be your angles. And then the last one, you need to prove this using similarity. So there I'm just gonna then guide you that you just need to try and prove that two triangles are similar, and then you will be done with that. Guys, so far what we've looked at is you need to recall the conditions for similarity, the midpoint theorem and its converse, and also the similarity theorems. Please give reasons for each step when solving a rider, and that's our mind map. If you don't give me a reason, I promise you, it's really gonna be a problem, because then you are just claiming and you don't have a base for your claim. Guys, from me to you, I hope you've had so much fun, because geometry is really a nice topic for us to do. But from me to you, the maths doctor, remember, maths is food for the soul. Until I see you next time.